Yay!
Yay! Okay, here's another example of what pressure really means is like a force on the inside of a box, let's say with air in it. So let's suppose that we have a box of sides 20 centimeters. And let's say I put 3 moles. That's actually going to turn out to be a lot. Suppose I put 3 moles of air, of gas. It turns out it doesn't matter what kind of gas. 3 moles of it inside the box. And just sort of a standard temperature and pressure. Okay, so let's put 3 moles of gas inside of this box at some standard temperature, 200 or 300 Kelvin, right? Room temperature. And let's see what happens. Let's see what the force is on each side of this box. So first, let's calculate the pressure. So what is the pressure inside the box? The pressure is just going to be nRT divided by V. Right? The number of moles is 3, so it's just going to be 3 times 8.31 times temperature is 300. Okay, the volume of the box is going to be, it's cubic meters, all right? So 20 centimeters, that's 0.2 meters cubed. All right, and when you plug these numbers in, what did I get? About 935,000 pascals, 935 newtons per square meter. That's a lot. That's what 9 times atmospheric pressure, pretty much. So what's the force on each of these sides of the box? Well, remember, pressure is a force per unit area. So the force on a side of the box is just the pressure times the area. So we sort of back this out a little bit. It's 935,000 times the area of one side of the box. That's 0.2 squared. And when you do this, you get something like 37,000 newtons. That's a lot, right? That's like 9,000 pounds of force on each of the sides of this little box, which is a heck of a lot. But this is how you calculate the pressure. Pressure is just how you calculate the force. Force is the pressure times the area.